So the next presenter, which is Michael Baumann. Mr. Baumann is product manager at Karakun, and he will talk about a solution based on the ADAM ODS standard using also OpenMDM application model and the OpenMDM API, which allows users to implement a data-driven engineering process by systematically exchanging and managing so-called functional data. And I think Mr. Baumann will explain us what functional data means and what the solution looks like. It's up to you.
So thank you. I hope you hear me and you see my screen. Thank you for the introduction, Mr. Kramer. Mm-hmm. Maybe just before I begin with the slide deck, some words about me. At Karakun, as Mr. Kramer said, I'm the product manager for our digital engineering solution products. Digital engineering solutions, in that case, mainly mean data management systems in our product portfolio, where we have both own products and also provide software development services. Today, I will talk about an own product. Okay, let's start with the presentation. 2 slides as an introduction, what it is about actually. The system is made for dealing with component system properties for functional development. These properties that are normally curves, characteristics for mechatronic components and systems or hydraulic ones, doesn't matter. But these properties in total define normally the DNA of a product. So besides design, for instance, but many functions like of a car that can be experienced by customers, like handling, so driving dynamics, driving comfort, noise comfort, and so on, durability, depend on such properties of components and systems. We call these properties functional data, not only we, but also a working group. I will talk about that a little bit later. Others call it also technological data, for instance, or just parameters or parameter databases are known. And we developed a system, a data management system for that, which is really totally data-driven. The base system actually is like a geometry PM system with some important differences. It's made of functional data. That's the first difference. And we deal with, or we work with, component-specific data models. So a data model of a battery system is another one than a data model of a shock absorber. That has reasons because we want to automatically quality check and automatically forward the data to downstream processes. We went a little bit beyond of that and also included additional functionality that you see here, right to that plus symbols here. So we also included a components requirements management capability and order delivery management for supply integration, because normally the data is being delivered from the external component system suppliers to the car manufacturers in that case here. And we also started developing process automation capabilities. There we are somehow in the beginning to make parameterization processes, for instance, of multi-body simulation models much more efficient than today. That EXOKNOX application uses an extended OpenMDM model. We took the NVH model and extended it for our purposes. So, and that will be the content of the next, I would say, 15 minutes here. Just to get things a little bit sorted. When we put the product in the middle. Here it's a Mercedes car. Before I worked with Caracun, I worked quite a long time with Mercedes as a simulation engineer. If you deal with these products either in hardware or as a simulation model in software in the R&D context, then you need information that is shown here below to build up such a system. So you see here data required for the definition of complex mechatronic systems. And for us, the absolute basis, I could explain why, but that would take a little bit too long maybe. The absolute basis is functional data. If you use, then there's other data like geometry data, of course, geometry related data like joining technology, materials information, materials data, the product structure to assemble everything together, and then you have that product. And if using that product in the R&D context, you apply maneuvers or load cases to it, you have tracks, you drive over, and in the end you will collect huge amounts of result data. That result data part here was the content of the last year's presentation here at the OpenMDM Summit. Hans-Jörg Walter presented last year. And today I will talk about the other end. So there is somehow a bracket around that development process here that we made with these two products. And as you see here, managing materials, data, materials, models, there we also feel at home because if you take a look at these symbols here, these pictograms, the quality of these data always looks somehow the same, and our concepts like automatic quality assurance processes and so on can be applied to all of these different tasks here. So if you're interested, just as an annotation, how classical simulation data management systems can be sorted into that view here. They normally are standing orthogonal on these specialist data provisioning systems here. Okay, why did we start development activities? When starting our activities, no functional data management system just was available at the market, meeting our requirements. So our requirements were both providing both real product data management principles like status, roles, rights, versioning was very important to trace the evolution of the data and to also be able to trace it back. And as I said, we wanted a data model representing component-specific details, no black box, like named channels, comprehensive metadata, like test conditions and so on. That was very important. And what else inspired us to develop a functional data management system? For me, when starting with it really a couple of years ago, it was speed. As a former simulation engineer, I and some of my colleagues know the pain points when it comes to handling functional data. For instance, just as an example, when doing a parameterization for a multi-body simulation model, for an entire car multi-body simulation model, it took us several weeks. And that could be, in the end, we are not that far, but in the end, it could be replaced by a one-click solution if you have comprehensive and functional data of high quality. That's that point here. But that's a little bit in the future, but we're working on it. A closed process chain for functional data management. The most important thing is that the entire development organization, following a single source principle, should work on the same data, because these functional data, as I said, they somehow make up the DNA of the system, should be developed transparently by all involved internal developers. And as I also said, a seamless supply integration was important for us. Future proofness, also important. I already mentioned the traceability. That's important for the upcoming digital certification. That will be really a point. And for us, it also was important to base on standards, and therefore we co-founded a standardization initiative that's today hosted in the ProStep EVIP Foundation called FDX, which stands for Functional Data Exchange. So, and since we rely on a variety of standards, we try to avoid vendor login, which you also achieve somehow. So mainly no vendor login with respect to the hyperscalers, for instance. How did we do that? We created a unified digital workplace for all product development stakeholders. That was one of our goals, as I said. And that really flexible data-driven approach, we'll see it later on in a short live demo, uses that, as I said, extended data model in the own ODS server, but also other ODS servers are capable to be operated together with that solution here. Because, of course, ODS is standard. So the solution is based on two pillars. The first pillar, as I mentioned, is the FDX data exchange standard. And that FDX format, as I said, is hosted by the ProStep Foundation. Founding members are quite a lot of car manufacturers like Mercedes, the VW group. So Audi, Porsche, VW participated. Stellantis is active. Ford was a founding member. And that FDX data exchange pillar uses OpenMDM, and of course, therefore, other ODS as an underlying standard. The second pillar is our software solution. As I said, the implementation of product data management principles was very important for us to realize that closed process chain and the realization of that one source principle, so to let or enable all the engineers to collaborate on the data is another very important point. So one remark, I needed to make a decision quite a couple of years ago when we started the development, and I decided to use the OpenMDM data model. And looking back, it was good because it provides a really elegant solution for us for data model evolution. We don't have any problems with respect to data model evolution. Different versions of the component-specific data models coexist in the database as separate templates, separate OpenMDM templates. So, for instance, one data model for a chassis component evolved over time, and now the customer project, we have version 6 in the system, but also version 1 still is available with the data that was made for version 1. So that is really an advantage of that OpenMDM data model, that template-based approach. Very briefly here, I have the text box on the right so that you have something to read when that document is being distributed after the meeting. Just 3 takeaways maybe. That's one development cycle that represents that closed process chain here. Really closed it here. Just for you to keep in mind, the first part is a very standardized functional requirements management. Then here in that lower part of the V, we have a supplier integration in terms of order delivery system that is built into the software. And here, the most important thing, because of that, we are doing all the stuff. We want to feed downstream processes. And here we have a automated transfer of measured data to simulation data, and later on a backstream of modified data and versioning, as I said, to track the evolution of the functionality of components and systems. Okay, so what? The last two slides, and then I think I have some minutes left for a short live demo. Here you see the system. It's a rich client. It's also a decision I made quite a while ago. As you see here, we also have status, like we saw in the Siemens presentation, but our status are different. That's not somehow a quality status of something. It's more a data management status. So the green one, for instance, is released. The yellow one is work in progress, but not ready for release. And dependent on these status, there are visibilities connected. So data that is not released is not visible for everybody. But data which is released is versioned. You don't get it out of the system anymore because of the traceability topic. You have a powerful search. There's a lot, just that you get a brief impression, of course, a plotter and so on, different metadata editors. That's my last slide. I would like to switch to a live demo, and I just thought about what could be interesting for you here in that meeting. And I just wanted to focus on some capability, so finding data. I switch to the system. If I find it here on my desktop. Yep. So it looks like this. It's a test system with just some test data, so I can search for everything here. Just to show you what is in the system. Of course, in customer systems, there are 10 or 100,000 of data sets. And but we also have some data sets here. So behind these bundles that are containers for data sets, how we call them bundles, you will find a couple of data sets that describe a component in their physical functional behavior. So, and there are different options to find the right data. For instance, just minimize it here. As you see here, there are two different part numbers. Everything is organized part numbers. And I could search for tags, for instance. So if I would search for some milestone, like the advanced development, the very early stage, I search for any text, then I find something. So two data sets, and just if I put that here to the working area, selection area, you see here a tag. It's apparently there are data sets for durability variant of bushing. Here, bushing is chassis bushing. Classical tuning element for the advanced development stage. Okay, what else do you see? You see some pre-information, what you have in the data sets, just to have a first impression what you can expect. But I would get back to the search. Other capabilities of searching are, for instance, searching for channel values, like for forces. So if I search for any now quasi-static measurements, let's say between 10 and 100 kilonewton, I will find nothing because I said the minimal force. Okay, so the maximum between 10, plus 10 and plus 100. And you see, you'll find that's classical data management capabilities. You find something, you can see it here in the object details, that is measured up to, you see it here, up to 50 kilonewton here in these cases. You can search for other stuff like for some geometrical information like sleeve diameters, bore diameters for screws and so on. All of that is part of the data model here. And these data models we develop together with our customers, everything they want to have to describe the component and the content data is part of the data model. Following the principles of ASAM ODS, describing the unit under test, describing the test equipment and the test sequence. Okay, so that's how we can find data. The second thing that I would like to show you is the data editors. We have different ones. I want to show you the dataset editor with the context-sensitive representation of a very big data model we work with. I just maybe bring that one and I load, because I searched only for these specific data sets up to 50 kilonewton. I load all the data sets of that bundle. And if you now open such a dataset editor, I enlarge it here. You will see here unit under test, test equipment, test sequence. You might be quite familiar with it. Just wanted to show you that approach. For instance, here for the test sequence, there are preloads. People that are familiar with testing might know preloads. And if I say yes, there's a second preload, you see that a preload 2 section appears here with attributes which seem to be mandatory. So the users want to force themselves to fill in information here because that is information they later want to search for instance. So the motion direction, of course, is important. Something like that. It could be the force regime, and it could be 1000 Newton. So you see, there's a very large data model behind, and we always show in a context-sensitive way only the information the user needs, just to keep it handleable and as easy as possible. So that is what I wanted to show you, how a very big data model, we talk about, I think, nearly 1000 attributes and curve types of channel data types in total, and that could be a way how to represent a very complex data model also to users. I don't want to save that here at the moment. Okay, data comparison. So just I can visualize it as you see here. So I get the different curves. I could also compare it in a tabular way. I could only show the differences here. So there are different capabilities of comparing the data which are in the data sets.
Mr. Baumann, we should come to an end, please.
Yes. And last thing, just an automation. That only works on a protected or released bundle. So I release that bundle, then versioning is active and it can't be modified anymore. And if I just show you automation, it runs a couple of seconds when the environment on the server side is started for the first time. And now this afternoon I'm doing it for the first time. But you will see that a new bundle will appear here that is especially made for parameterizing simulation models, and simulation the data can directly be exported and imported into a simulation model as it comes from here. So also parameterization data for the simulation models we have in that system and can fully trace them back. Okay, so I'm finished with my presentation. Since it's quite late, I propose if you have any questions, just to approach me after that meeting. Mr. Kramer will distribute the slide deck, and here you see my email address.